Okay, so before we actually get this final drape finish, let's take a look at the vellum solver SOP here, because it's really handy. So kind of got what, you know, the typical things you would need. Ground plane if you need that. We don't for our sim here. Can turn off the collisions, turn off collisions with yourself. Time scale if you wanted to slow down or speed up a bit. Obviously sub steps, your constraints, and all the different iterations and passes here. Typically now, to be honest, I just raise the sub steps. You know, I won't play around with these unless I'm really struggling with really long simulation times. I'll just push up the sub steps because that's gonna multiply any of these, right? In the past, you know, they recommended kind of playing around, dropping constraints iterations if you raise the sub steps and all that, but now just raise the sub steps. You know, vellum's so fast as well, it's often simulation times are often not too much of a problem. You do have this thing, layer shock here, which I haven't really used myself, to be honest, but it's used for when you've got lots and lots of different layers of fabric on top of each other. You can set an integer attribute to each one, which tells the solver which layer of cloth has kind of priority. So cloths which are lower down will have a higher mass, I believe, and cloths which are higher up will have a lower mass, so they can move out of the way. Basically, you can read, you know, that what it says. Other things we got here, so obviously we got things like wind, drag, velocity damping will just kind of generally slow down the velocity as if, you know, he's underwater or something. We got friction controls here, so we don't ever touch that really. You can turn on the multi-pass solve, which helps. You can try that out if you've got problems with collisions, but it can be quite expensive. It takes a lot. It can slow your simulation down quite a lot. This can be useful to drop down to maybe 10, 20 or 10. If you find your simulation's kind of bouncing and has some weird movement to it, maybe bring this down to 10. And then it's using OpenCL there, which is good, nice and fast. Sorry, leave that turned on. And then visualizing this is really interesting as well. So you can look at the thickness. You don't need to, again, this is not too problematic now as it was in the past. Failed collisions, which we won't see yet until we start simulating. We can look at the welds that we just made. Okay, again, these are not constraints. We can look at the constraints that we've made. So we don't have any pins, we don't have any stitches, but we got attached to geometry. So we got these at the bottom, these around the belly, and then also the trousers at the, well, we know they're there anyway, we don't need to see them. And then what's also really cool is that you can look at these different stresses. So if we start to simulate this, just do a couple of frames. This is going to look horrible to see it's all stretchy there because we don't have enough sub steps. But we can look at the stretch stress there. You get a nice kind of visualization of that. Bend stress, stretch ratio, these weird different things. And really what that is handy for normally is for breaking things, right? So we can just try this out. You know, we're not going to obviously break it now. We'll be doing that later, and I'm going to be doing it in a bit of a different way. But yeah, we can set this up here, and we can set it to stretch stress threshold. Excuse me, threshold of 0.1. So we can use that here, set it to 0.1. And maybe visualize these welds, and then maybe we'll see some of them break. So you can see that we're not reaching that kind of bright color, you know, that we were seeing before. So let's drop this to 0.02 maybe. 2. Still nothing breaking. You know, we don't have a lot of stuff going on there. Let's do 0.5. 0.5. This is not going to affect the simulation in any way. It's just the visualizer, remember. There you see, when it gets, see where it's red here, these are starting to break now. And there. See, around the waist, that's where, because we got all the weight of the trousers pulling down, and then we're starting to see rips forming on the trousers, which is cool. Okay, so you can use that to kind of pinpoint, right? So this part is under enough stress to rip now, but we don't have any cuts there. At the back, there's less. Okay, so you can use that for art directing your, you know, how things tear and stuff. But I'm going to turn that off now because I don't want it to rip. We made a bit of a mistake here. We just need to connect this up with the blend shape so we actually have that animation. Get rid of this null. And let's see, I'm going to turn off, there shouldn't be purple in it. Oh yeah, turn off, I don't want any visualization on there. We don't need to see it. Maybe just the failed collisions, if there's anything serious. Welds, we don't need to see them either. I'm actually going to turn this up to 10 sub-steps. And just let this play out. I'm going to let this cache out maybe, I don't know, like 30, 40 frames, just to a point where it relaxes. And I'll come back once that's done. Okay, I've just stopped it there. I've got a bit more than, I've got quite a few, got 60 frames, but I'm just, if I just go back there, you can see around there, you know, it's not moving much more now. Okay, maybe the collar's kind of flapping around a bit, but yeah, just after it stopped moving, I'm just going to go there, and I'm going to drop a vellum IO, which basically is for caching vellum sims. Okay. Probably don't need to really use this, but what is handy with this is that it helps you delete out all of these attributes you don't need. Okay, but it will save constraints and the collision information as well if you need it. We don't in this case, but just to show you that it's available, and it's kind of handy for that. So I'm just going to save the current frame. Got frame 50. It doesn't matter as long as it's you know, it looks settled for you. And then let's see, I'm going to save it to my hip into, yeah, geo is fine. Let's call it, let's make a new folder and call this drape, just in case you want to do more than one. Call it drape version 1. I'll save it as a geo, and we don't need the frame number. Cool, save to disk, load from disk, there we go, and then wherever we are, we've got this information ready to go. I'm also going to, so you can see that we're still, if I drop a null after this, so I'm going to discard, I'm going to leave the constraints and stuff. We still got all this vellum stuff going on, right? So, excuse me, I'm going to attribute delete all of this stuff that we don't need. So delete all of the point attributes. Vertex, we want to keep the UVs. Everything but the UVs. So star for everything. Little, I don't know what this symbol is called actually. Little hat. I think people call it carrot maybe. I don't know. That means except for UV. Primitive. Let's see, what do we have? Get rid of the dop object name and name. Yeah, we won't need that. We got groups everywhere. Detrol attributes. We'll get rid of all of them as well. Okay, so this is nice, just plain geometry to go back into our simulation, okay? Because we're going to be mixing things together, I don't want any weird, you know, that could be problematic. You need to be very careful with attributes when you're, you know, using taking one simulation and then putting that into another one. You know, when I was doing tests on this, I was getting weird. It just wasn't behaving correctly. So this is how I found it to work best.